Hello everyone, I am Dr. Abha Kumari from Nirmala College. Today we will discuss the particular integral of type 3. So in type 3, this is of type 3. So in type 3 we will discuss the exponential case. Exponential case. When f of AB equals to 0. So let us see how can we solve such this type of problems. So in this case, let us see first the working rule. Working rule. First, so to evaluate 1 by f d dash phi ax plus by, what we do when f of a b equals to 0, we proceed as follows. Step 1. First is step 1. So what we do in step 1, we differentiate f d dash, that is comma, and with respect to d, and d is a function for x, partially, and multiply the expression by x, और जो भी हमें रिजल्ट आएगा हम उसमें x से मल्टीप्लाई कर देंगे. So that f1 by f, whatever the function is, d dash phi ax plus by will be equals to x से मल्टीप्लाई करेंगे और यहाँ फंक्शन को डिफरेंशिएट करेंगे. जो भी रहेगा टर्म आपका दिया हम उसे क्या करेंगे, डिफरेंशिएट करेंगे, एंड राइट द फंक्शन इन टर्म्स ऑफ phi ax plus by. This one is the step 1. Not step 2. No, sorry. Yes, step 2. In step 2, if f dash ab is also 0, while substituting the value of d and d dash, if we get the f dash ab again equals to 0, then we differentiate. So again we differentiate f dash d dash partially, okay, with respect to d, and multiply by x, so that अब हमारे पास टर्म क्या था, ये टर्म थे, तो ये टर्म अब किस में कन्वर्ट होगा ये देखते हैं. सो x इंटू 1 बाई एफ डी डैश phi ax plus by is converted into x square 1 by f double dash. Here is f dash. So again we differentiate this term and again multiply x. So after multiplication of x we get x square, and f dash will be equals to f double dash d dash, and then phi ax plus by, and then proceed. This type of differentiation we repeat. Now we proceed this type of differentiation again, and every time we multiply by x as long as the derivative of f d dash vanishes. That means ये अगर 0 होते जाएगा जितनी बारी उतने बार हमें x से मल्टीप्लाई करने हैं और उसका फिर से डिफरेंशिएशन फाइंड करना है. When d का वैल्यू क्या है, a, and d dash is equals to b. Now type 3. So now step 3. What we do in step 3? If 1 by f d dash, here is your f, so 1 by f d dash phi ax plus by equals to fr ab not equals to 0. अगर ये 0 नहीं होगा तब क्या करेंगे, fr ab not equals to 0. Then 1 by fr ab phi ax plus by can be evaluated by the type 2. So earlier we have discussed the type 2. So here we apply that rule of type 2 if we are not getting FRAB equals to 0. That means FRAB not equals to 0. Then we have to apply all the steps of type. For example, 1. Solve 4 into r minus s plus t equal to log 16 log x plus 2y. Log, here is x plus 2y. That means 4 bracket r minus s bracket close plus t equal to 16 log x plus 2y. So how can we solve this question? Solution. So I'm leaving the CF part because you all are well known with the complementary function. So we only do the PI part. So now PI. 1 by 4 times d square. So d square means what? Del 2 z by del x 2. Here is r. So we are putting this value as d square minus. Next is what? R. S is what? S is for del 2 z by del x del y, and we are writing this value as d into d dash. So d square minus d dash. Now bracket close. Here is a plus t. So plus d dash square. And then we have 16 log x plus 2y. Now applying this rule, now what we do? We put the value here as d 1 by coefficient of x is 1. So we put the d equals to 1 and d dash equals to 2. Why? The coefficient of y is 2. So pi. So what the pi becomes? So pi is equals to 1 by 4 into 1 minus 2, 1 square minus 1 into 2. So 2 plus 2 is square, that means 4. 16 log x plus 2y. So here we see that this value in the denominator. So here f 1 comma 2 is equals to what? 0. Why? Because here is a minus 1 and the minus 4 plus 4 we will getting a denominator as 0. So here f1 and comma 2 equals to 0. Therefore we have to apply the rules of type 3. So therefore pi equals to what the pi becomes? We will multiply with x and differentiate. Differentiate which part? This one. Now differentiating this one, what we get? 8d. Here 4d square. So we are getting with the 8d minus what we get? 4d dash. 4d dash. And then plus minus 4d dash, and here is the d dash square. So this part will be equals to 0 because we are differentiating partially with respect to d. Here differentiating partially with respect to d. So we getting 8d minus 4d dash, and the next one is 0 because we are differentiating partially with respect to d. So 16 log x plus 2y. Now we again put the value of d and d dash here. So we get x into, so just write this one as 8. So 4d minus 2d minus d dash 16 log x plus 2y. Now again put d equals to 1 and d dash equals to 2 in equation number. If you put this as equation number 1, that put this as 2. In 2 we get, so what we get here is, so pi equals to x into x square. Why x square? Because whenever we have to write the f, we are getting to put the value of d equals to 1 and d dash equals to 2, then we have to multiply. So here is x square into 1 by, so 2 into 1, 2 and minus 2. Again we are leaving with a 0. So we again differentiate this term. Okay. We get that f dash d1 comma 2 again equals to 0. Therefore, so pi is x square 1 by 4 into 2, 8. And then 16 log x plus 2y. Why this one? Because when we are putting the value here is d equals to 1 and d dash equals to 2, we again see that our denominator is equals to 0, and since this denominator is f dash d, and that's why we again apply the rule of the exponential function, that is type 3, and therefore our pi becomes x square 1 by 4 into 2 differentiation of d with respect to d partially, we are having 1 here, so 8 into 1 minus 0 because d dash is here and we are differentiating partially with respect to d. So we are living with the value x square 1 by 8 16 log x plus 2y. So now cancelling this to value 2, so our function is 2x square log x plus 2y. This is our the pi part of the given function. So let's see some another example. Second question. Question is dq minus 4d square d dash plus 4d d dash square into z equals to cos 2x plus y. So here cos 2x plus y. So solution. Again I am leaving this complementary function, so you all do it very well. So now I am doing only pi part. For the pi part we have 1 by dq minus 4d square d dash plus 4d d dash square into cos 2x plus y. Okay. Now put d equals to 2 and d dash equals to 1. Since it is a homogeneous function, that's why we are putting here d equals to 2 and d dash equals to 1. If it is not a homogeneous function, then we apply the previous rule and we are putting here d square equals to minus 2 square and d dash square equals to minus 1 square if it is non-homogeneous linear differential equation. But since it is a homogeneous linear differential equation, that's why we are putting here d equals to 2 and d dash equals to 1. Okay. So now proceeding, we have this one. So what we get? Therefore, f d d dash. What is f d dash? So here we are getting 2. So 2q means 8 minus 4 into 2 square. Again 4 into 4, 16 plus 4 into 2. We are getting 8 into 1. So here is 8. So 8 minus 16 plus 8, that is equals to 0. That means f d d dash again equals to 0. So therefore what our pi becomes? Pi equal to x into 1 divided by, now differentiation of this function partially with respect to x. So 3d square minus 8d and then plus 4d dash square, and then we are having cos 2x plus y. Now again we put, what we put here again? So put again d equals to 2 and d dash equals to 1. So what we see here? F d d dash equals to, so what we get f d d dash here is 3 into 2 square, that means 4 minus 8 into d 2 and then plus 4 into 1 square, that means we are having here 12 minus 16 and then plus 4, 16 minus 16, that is equals to 0. So again we have f d d dash equals to 0. So the pi equal to x square. So again we multiply here the x. So x square into 1 divided by 6d minus 8 and then plus 0 and into cos 2x plus y. Isn't it? Now again we put the value of here. So again put d equals to what? 2 and d dash equals to 1. We are getting, here is the f dash now. So f dash. Now f double dash. So f double dash d equals to what? So f double dash d dash equals to, here is the f double dash. So in putting this f double dash, we are to 6 into 2. That is 12 minus 8. We are leaving with the 4 not equals to 0. So what we do here, we apply the previous rule, and from the previous rule our pi is equals to what? X divided by, that is x square, 12 minus 8 integration. Why integration only one time? Because we have d here. Okay, so integration of what? Cos 2x plus y and dx. But what we do here, we put here t. So t and then dt, where t is what? 2x plus y. So here cos t and then dt. Cos t and dt only one times. Why? Because here we have d. So this is equals to x square divided by 4 into, we are living with a sign t, and that is x square by 4 sine 2x plus y. So this is our pi part when we have the function like this. Thank you. Next day we will come with the next type of questions.